Okay, my video got interrupted, so we're gonna pick it up right here. We were at the least common denominator. We multiplied everything by the least common denominator, but before we did that, we simplified first. So we're simplifying right here. Now we're gonna just multiply what we can together. So I multiplied 28 times x minus 4 plus 9 times 48. So that's where I was at. 9 times 48 is, should be able to do that in my head. 432 equals 55x plus minus 220. Okay, now let's see, this is 28x plus 320 equals 55x minus 220. This is minus, if I subtract 320 from both sides, I get minus 540. I'm going to subtract 55x from both sides. I get minus 55, that's negative 27x. Negative 27 goes into there 20 times. And so that should be the answer. Okay, so always double check your answer, of course. I've got, when I double check it here, I'm going to quick double check 7 twelfths plus 9 sixteenths is at 55/48. Okay, so let's check that out. This would be 28/48. This would be 27/48. Sure enough, it's 55/48. So it checks off. Okay, so that's how you should have done that one. Let's go on to example 2A. 2A, it's going to be a little bit different, but not too bad. Okay, so here we have y minus 2. We have a 1 for a denominator, that's nice, and then a 6. So my least common denominator here is y minus 2 and 6. So we're going to multiply by 6 and y minus 2, 6 and y minus 2, and 6 and y minus 2. 6 is canceled, leaving me 17 times y minus 2, 12 times y minus 2, and 30. Okay, so let's go ahead and do those. We have 30 plus 12y minus 24 equals 17y minus 34. Subtract 17y, I get negative 5y. 6, I'm going to subtract 6, I get negative 40. Y is equal to 8, and we need to double check this, so let's do that. Never assume that it's going to be okay. 5/6 plus 2 equals 17/6. This is 12/6, and that works. So it is the correct answer. All right, so let's go ahead and do 3 more examples on example 2. There's a 2B, 2C, and 2D that we should talk about. There's a couple things in those that you need to know about, so let's go through those. Basically, we're going to use the same concept, the same solving method to do these. It works out pretty well. But, like I said, it's going to get a little trickier as we go. So 2B is 2 over z plus 1 minus 1 over z minus 1 equals negative 2 over z squared minus 1. Okay, so now we've got a quadratic in the denominator, which of course is going to be the same way of solving it as we did before, just have to deal with a quadratic. So the least common denominator, the LCD, we know this is z minus 1 and a z plus 1 together. So we know that this is z plus 1, z minus 1. So basically it's z plus 1 and z minus 1. So there's a z plus 1 and a z minus 1 in the denominator. So we're going to multiply everything by z plus 1, z minus 1. Okay, so when I do that, of course, z plus 1's cancel, leaving me with 2 times z minus 1. The z minus 1's cancel. I'm going to go ahead and move the minus up, so that leaves me with negative 1 times z plus 1. And then these both cancel, leaving me with negative 2. Once you get to this point, you should be able to solve pretty easily. You're just, of course, multiplying like we did before. So let's see, we got z minus 3 equals negative 2. Add 3, we end up with z equals 1. Now, just like I said before, you have to make sure that you check your answer. If I put in 1 in for z up in the original problem, if you notice, I'm going to get 0 in the denominator. It does not work. It does not. It's called an extraneous solution. So in other words, my answer is no solution on this one. There is no solution that will work. The only solution that came up was 1, and that was extraneous. All right, so let's go to 2C. Guided practice 2C in your book. You can always try these on your own in your book and pause the video, come back and see how I did it and see if you can do it on your own. All right, so let's go over these. All right, so we need to factor this. Let's go ahead and factor. We've got 3n plus 1, 4n minus 1, and 2 and n plus 1. So basically, we need to be able to come up with a least common denominator that's going to work for all 3 of these. Looking at the numbers, we've got a 3, a 4, and a 2. So the number that goes into all of those has to have a 3 and a 4, so that would be 12. Also has to have an n plus 1, also has to have an n minus 1. So the least common denominator is 12, n plus 1, n minus 1. So I'm going to go ahead and write those down. 12, n plus 1, n minus 1, 12, n plus 1, n minus 1, and 12, n plus 1, n minus 1. Now I'm going to cancel the denominators out so I can multiply what's left in the numerators. Okay, so this cancels out 3 and an n plus 1, so leaves me with a 4, so 7n times 4 times n minus 1. Four n minus 1 goes into here, 3 left, n minus 1 cancels, so leaves me with a 15 and an n plus 1, 5 times 3. These two cancel, leaving me with a 6 here, and an n plus 1 cancels, leaving me with 18n times n minus 1. Okay, so this leaves me with 28n times n minus 1, which is 28n squared minus 28n. Minus 15n minus 15. 18n squared minus 18n. And there's my equation. Now, it is a quadratic equation. So that means that I have to turn over to the quadratic solving methods that we learn in chapter 4, whether it be factoring, quadratic formula, or anything like that. So I want to get everything on one side because it's quadratic. So I'm going to go ahead and bring these over, everything over to this side. Leaves me, I'm going to subtract 18 from 28, gives me 10n squared. I'm going to add 18 to negative 28, leaves me with minus 10n. Oh, but then I have to subtract 15. So let me do this over. I've got negative 28 minus 15 is negative 43. Negative 43 plus 18 is negative 25n. And then I'm going to minus 15 equals 0. Now, I'm going to factor out a 5. Two n squared minus 5n minus 3. Factor this. I'm going to make sure you guys can see that. Looks like I'm getting down there. Factor out the 5. I got 2n squared minus 5n minus 3. I got 2n here, n here, minus 3 here, plus 1 here, equals 0. So I know that my solutions should be n equals negative 1/2 and 3. For the sake of time, I would, if this was a test, I would plug in both of them to see if they work. So to save time, I'm going to just go ahead and look at it here, and it looks like they are both correct. They both work. There is oftentimes a chance that one of them won't work. Or both, even. That's why you have to check both. All right, the last one from example 2 in the book. (2d), I have 1 over p minus 2 equals 2p plus 1 over p squared plus 2p minus 8 plus 2 over p plus 4. All right, so if I go ahead and factor this middle one, I end up with p minus 2 and p plus 4. So basically the middle one is made up of the other two. So my least common denominator basically is these outside two, p minus 2 and p plus 4. So multiply everything by p minus 2 and p plus 4. This eliminates this, leaving me with p plus 4 here. This eliminates the whole thing, leaving me with 2p plus 1. And this eliminates this, leaving me with 2p minus 4. It's 4p plus minus 3 minus 4p minus 4p. I get negative 3p minus 4 equals negative 7. So p is 7/3. Again, plug it in to make sure. but that is the correct answer. Okay, so hopefully those 6 examples get you where you need to be with solving rational equations. We saw some pretty good ones in there, and we're going to not do the word problems, but I'm going to go over inequalities here in another video.